Here we're using the formula for arithmetic series. An arithmetic series is the sum of the terms of an arithmetic sequence. The formula for the sum of the first n terms of an arithmetic sequence is capital S subscript n, which is equal to n times the first term plus a subscript n over 2. Given the terms of an arithmetic series, find the sum of the first n terms. Number 1, we need to first identify the first term and a subscript n, which is the nth term. Then we need to determine n, and then substitute the values for a subscript 1, a subscript n, and n into the formula, and then simplify to find s subscript n. So, in part A, we want to find the sum of the arithmetic series. So we have 5 plus 8 all the way to 32. So, we can see here that 5 is the first term. That is identified as a subscript 1. And then we can see that the nth term is going to be the last term, which is 32. So now we identified a subscript 1 and a subscript n. Now, we need to count the number of how many terms that we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So counting the number of terms in a sequence, we find that n is equal to 10. And then what we're going to do is we're going to substitute those values for a subscript 1, a subscript n, and n into the formula and then simplify. So we have s subscript 10. We know that n is 10. We know a subscript 1 is 5. A subscript n, which is the last term, is 32, and then divide that by 2. So 5 plus 32 is 37. Times 10 is 370, and then divided by 2 is 185. So the sum of the first 10 numbers of the sequence is equal to 185. Next, we have 20, 15, 10, and it goes all the way to negative 50. So again, we have to identify the first term of the series, which is 20. We can see that the nth term is negative 50. And then we're going to use the formula for the general term of an arithmetic sequence to find n, because if you look at this example, we don't know how many numbers are in this series because there's a dot here, so we don't know. In order for us to figure out what n is, we have to go back to the arithmetic sequence formula, which was a subscript n, which is equal to a subscript 1 plus n minus 1 times d. Well, we need to find out what the common difference is. Well, the common difference is taking the second term and then subtracting 20 from that second term. So 15 minus 20 is negative 5. So we're going to plug in d to be negative 5. We know that the nth term is negative 50, and we know the first term is 20, and that's going to allow us to find out what n is. So the first thing we're going to do is we're going to subtract 20 to both sides. So we get negative 70, which is equal to n minus 1 times negative 5. Then we can divide by negative 5, so negative 70 divided by negative 5 is 14, which is equal to n minus 1. And then if we add 1 to both sides, n is going to equal 15. And now what we're going to do is we're going to substitute the values for the first term, the last term, and the nth number into the formula and then simplify. So s subscript n is s subscript 15, which is going to be 15 times 20 minus 50 over 2. And the answer is going to give us negative 225. In part C, we have the summation, k is equal to 1 to the upper limit of 12, and the formula is 3k minus 1. So the first thing we need to do is to find the first term. In order to find the first term, we have to substitute k is equal to 1 into the formula to find out what a subscript 1 is. So let's plug in 1 into the formula. So a subscript 1 is going to equal 3 times 1 minus 8, which is equal to negative 5. Now we need to find the nth term. Well, the nth term is the last term, and the upper limit is 12. So when it's equal to 12, since we know that there's 12 numbers, we can then find out what a subscript 12 is by substituting k to be 12. So a subscript 12 is going to equal 3 times 12 minus 8, which gives us 28. So now we know that the first term is -5. We know that the last term of the sequence is 28. And we know that the numbers, the amount, is going from 1 to 12. So therefore, n is equal to 12. And then we're going to substitute those values into the formula. So s subscript 12 is going to equal 12 times -5 plus 28 divided by 2. And doing order of operations is going to give us 138.